We recently made updates to the Blue Rhythm AI tools that allow you to do a lot more and upload entire sequences of operation and other complex instructions that can then write very rigorous checklists and test forms. For example, instead of starting with an empty placeholder for a functional performance test, you can copy and paste entire sequences of operation without any regard to formatting or if the text isn't organized well. Just take this information and turn it into complete test forms with all of the different sections, test procedures, very rigorous and robust coverage. And if you decide to use the content that it generated, you have all of the sections of your test form automatically created. This will work the same for the other workflows that you need on your projects. So this is another step forward with the AI tools in Blue Rhythm, and we're excited about this and look forward to hearing your feedback.
Good afternoon. My name is Simran Maurya with the Energy Management Association, and I'd like to welcome you all to today's webinar and thank Blue Rhythm for sponsoring today's session. A few housekeeping items before we get started. Presenters will be holding questions until the end of presentation, but we encourage you to submit them at any time using the Q&A button. If you happen to be experiencing technical problems during the webinar, please use the Q&A button to inform the panelist, and our producer, William, will assist you. The presentation is being recorded and will be available for viewing within a week. In terms of continuing education credit, everyone in attendance for the full webinar will receive a certificate of attendance sent to their emails within 24 hours. And finally, if you are a certified EMP, your CEUs for attending this webinar will be automatically uploaded to your portal after the webinar concludes. Today's webinar is Elevating Campus Facilities Management, Tailored Strategies for Energy Efficiency and Commissioning Excellence. Before we dive in, a huge shout out to LaPera for stepping in at the last minute to share his expertise with us today. Kevin had to step back from presenting, but is available in the background for questions. Thank you, Al, for jumping in and ensuring we get top-notch insights on this important topic. Our speakers are Al LaPera with Kimley and Gordon Stead with University of Georgia. A little about our speakers. Al LaPera brings 47 years of experience in HVAC system design, energy auditing, and commissioning across educational, healthcare, and commercial buildings. His expertise spans planning, analysis, and construction oversight for optimized building performance. Gordon Stead, a commissioning engineer at University of Georgia, leads commissioning efforts across UGA's 7.8 million square feet campus, focusing on systematic energy savings for both new and existing systems. With a background in physics and engineering, he applies data-driven strategies tailored for large-scale campus operations. And without further ado, speakers, please take it away.
All right, let's get us started here. All right, I think we're clean and green here. I'm Al LaPera, and my friend here, Gordon. Say hello, Gordon.
Hello, Gordon.
I like it. All right. All right. So, Gordon, you run this obviously huge campus of 440 plus buildings, right? And from our brief conversation we had a little while ago, you said that you have some buildings that are as old, I think you, correct me where I'm wrong, I think you said 1883. So you have buildings that are bordering on over 140 years old that you are responsible for their energy consumption.
Yeah, I hesitate to say that I run the whole university. That's a bit of a stretch. But yeah, we need the commissioning effort on them. So yeah, according to our website, at least, Old College, which is in the top right of the picture, there is 1806 actually. So yeah, even more ancient. And then right through to the Poultry Science Building, bottom right there is 2023. And a vast campus of very many large and very many small buildings in between, with new construction on the way. And yeah, so it's a big campus. We're proud of it, and complexities all across there with the scope of the size, the diversity of the age of the buildings, and the age of the HVAC within them, for sure.
Okay. So, you know, it's like you were talking about, you have, like, think about it. If you have it, you have such a diversity of of types of projects that you have here, right? If I'm looking at it, you besides having obviously a natatorium, for a pool, you have some cooking, but then again, you got some other unique things. One looks like a robotics. Why don't you talk a little bit about the different types of facilities you have?
Yeah, and I'm sure there are many other facilities managers on this call, many other people who work in these universities who will, yeah, understand what I say when, it's not just a bunch of teaching spaces. In a way, we're kind of like a municipality, really. We've got every kind of type of building almost you can imagine. We've got them. So when you think about a university, you think about teaching spaces. That's kind of what I've got on the top row there. On the classrooms with a lot of people in a small space, through to wet labs with a lot of air changes. And then some unique spaces. So on the right, we've got our robotics lab. And if I understand, yeah, they've got an extra high seating there, which is designed for in-building drone flight testing. So all of these like weird and unusual spaces, a lot of them have a lot of energy use. And then outside of what we regularly think of normal teaching, we got our some veterinary surgery going on. Bottom left, basically healthcare aspects. You've got dining aspects to feed all those 40,000 students on staff, and we got a Olympic-sized natatorium from the '96 Olympic Games. So a huge range of types of spaces which need their own individual O&M and individual commissioning and energy management approaches.
And again, this is all probably which is leading into our next slide. That you have a district energy, whether it is, as you were telling me, you have chilled water which feeds the entire campus, or maybe are there some buildings I'm sure that are divorced from the chilled water campus. But for the by and large, almost everything is off of chilled water and district steam, right?
Yeah, any possible combination which is possible to imagine, we've got it. And so on the heating side, our campus works off steam to heating hot water conversion across campus, and then chilled water for the vast majority of our buildings and slightly more localized loops. And then when you look at your odd buildings here and there on campus, and most of our buildings off campus in our research areas, then they may be more sort of standalone units for sure.
Sure. Okay. But so as we dig into some of your plants here, like if we look at, you have your campus-wide steam to hot water, clearly steam, while it's an effective means, it's an inefficient means, right? And in trying to save energy there on a system, depending on the type, I think you and I talked about that a little bit, that depending on the type of traps that you have. I think you made what was the comment you talked about? How much wasted you actually from steam you actually get beneficial use from?
Yeah, so I think the steam plant itself runs at a pretty high efficiency, 86% or more. I know you can get more of boilers, obviously, for sure. Pardon me. So the initial construction of our steam plant was back in the 1920s, through to the 1960s, and in that era, steam was king, wasn't it? That was a way to transfer heat across distance. It made sense at the time. And I see bottom left, we've got some pretty new boilers going in there, which we've retrofitted over the ages. And the campus steam map in the center, top center, I've rotated on the side there just to fit in. There's I can't remember how many miles of pipe there is, a steam pipe across campus. And we had a energy utility master plan done for us recently, and the numbers which they came up with was only 35% efficiency in terms of the transfer of the heat from the steam plant to the heat exchangers at the extremities of that loop. So that's a lot of losses which you're getting. No one builds these today, right? People use heating hot water for that large scale distribution. But again, those of my colleagues in other universities of a similar age and scale will know that you can't replace those overnight. So it's a really, really long-term plan to transition to heating hot water. In the meantime, we need to work out what the best way is of managing that system energy-wise.
Okay. All right. Now that you found that, is there, clearly with being driven to save energy, right? So how do you what are some of the ideas that you're looking at on how to save some of the steam energy? Are you looking at cogeneration at some point, or?
Yeah, I mean, but honestly, this goes sort of outside my above my paycheck, shall we say, and
I know, I
outside
understand,
my
but
expertise. But yes, certainly the idea is to transition long term to heating hot water, and so the way in which the current plan is to not deal with it as a whole campus, but to break it down into. It's going to be the plan is for 7 separate self-contained heating and cooling districts. So to connect together the cooling and heating cycles, and parcel them out into those 7 little regions, which makes a whole lot of sense. But it's a big
it's a big undertaking,
many
sure,
decade long undertaking, and terrifying financial numbers when you look at it. But that's
and
the way forward.
and as a side note, which probably doesn't mean a whole lot here, but at least to my analytical mind, do you have trenches, or where this you can get to all this piping, or is this something when you wind up doing it? Because clearly, you're talking about a very evasive kind of project to start running to changing this pipe out.
Yes, I mean it's mostly buried pipe. So yeah, not easy to access, but then you get the steam traps and the trenches along the way. So yeah, it's as again anyone else who works with steam will know on certain days you go around campus and you just see the steam plumes coming up out of the ground, and you can map out pretty clearly where the steam line is going. What also is fascinating is every year we get a drone flight with thermal imaging done at night, and just to see through there the thermal imaging, the map of the steam line underneath, and to track leaks, which we get along the way is fascinating to see. That's a whole nother webinar.
Oh yeah, no, I get it. I was just kind of
course.
I was just looking at like how do you take an old system and try to make it more useful, right? Until you get there, right? So, but
and a big shout out to our guys who run the steam plant, because that is an enormous undertaking. Continuous 24/7, 24 hours a day, 365 days a year. And some really skilled expertise. Also, so we mostly run on gas, but we do have the ability to switch to fuel oil when under curtailment, and that is another skillful little thing to do as well.
Okay, all right. And so obviously you have district chill water. Do you have a varying age of plants in, like, as far as the machines? Are they all like how old are some of them, obviously?
Oh, and there's a huge range. I couldn't tell you the exact numbers. So we have
no. I'm just saying
we have 2 large. So we have five distinct loops, and within each of those loops, 2 of them have significantly large plants which anchor them. So top left there is our depth 1, which anchors our central campus chill water loop, and in there we've got 4 chillers with 6,000 tons between them. They're interconnected cooling towers on top, so that will anchor most of the central loop. So at this time of year, it'll just be chillers in that plant which is working. But then as part of that loop, you've got a bunch of distributed chillers in buildings. So in the summer, as a call for staging to go up and up and up, by mid-July, you've got everything, well, N+1 redundancy, but essentially you've got everything running to do that. And then in other loops, it'd be more just distributed chillers running off that. And I think, this whole concept of district energy is great. We can get much better efficiencies of scale. O&M is more concentrated. It's a great thing. We're not complaining about it, but it does have big complexities when it comes to energy management, especially in terms of just modeling everything. So, we don't have that metering of utilities in and out of each building that we would like currently. We're going in that direction, but it's a long and heavy lift. And so, trying to get a clear energy model for campus, EUIs for particular buildings, that data isn't available to the detail and resolution that we would like it to be. So that creates a lot of complexity, I think, in figuring out how best to manage our resources.
Are all your plants currently, are they primary, secondary? Do you have variable flow primaries running through your chillers, or are they? That's one of the reasons I was asking about the age.
Sure, yeah. I don't know. my expertise on the particular plants is not as good as I would like it to be. Let's say that. So there's a variety. We have staging on all of them. We have that's a lot of what my two excellent technicians do is working on that to make sure the staging programming is right, recording on the right units at the right time. So yeah, it's a variety, but that's how we run it.
Okay.
Yep.
That's fine. I'm noticing down in the lower right-hand corner there's some purple piping that you have. Is that that's normally I would normally say that's reclaim, but is that what that is? What
that's our makeup water for our chill water loop. Yeah.
Okay, so that's so you're doing it as reclaim?
There's some of that, yeah, for sure. But then that is the makeup water from the utility, from the municipality.
Ah, okay, all right.
Yeah.
Interesting. Have you in other energy management things that you're doing are there's been this current trend, and I'm not saying that you're going here yet, but there's been this current trend on the varying the water through the condenser bundles. Not all machines can do it because they weren't built to do that. Or do you have any of your plants that is currently doing that as a looking at energy savings that way by looking at where the energy peak is?
Not that I'm aware of, but I may be wrong on that.
No, it's okay. No worries.
Yeah. I think one of the many challenges we have with district energy, again, facilities managers will be familiar with this, is when you commission and do energy management on the loops, you really need to think of it as a system. So one of the things in our own internal planning, we refer to existing systems commissioning rather than existing buildings, and just thinking how they relate to each other. So if you have low delta T on one particular air handler on your connected load, that has an impact on the efficiency of the chillers upstream, where we have 3 pipe systems creating excess flow and low delta T, that impacts your chillers. So trying to manage all of those together is a lot of the complexity, and we certainly have a push to try and convert 3 pipe systems to 2 pipe systems for that. And I think another area which can often be overlooked is really such a simple thing as having a good cleaning program for your cleaning tower, for your cooling towers. And that sort of preventative maintenance can easily be dropped out. So one of the things I say for a campus of our size, and for any significant campus, is you can't really think of commissioning in the recommissioning or retrocommissioning mindset of like, let's do this building every 5 years or whatever, because you've got way too many to get through. So I think it's much better to think of it in an ongoing commissioning perspective and mindset. And so with ongoing commissioning comes preventative maintenance.
Right.
One of the things which we found is how critical cooling towers are. If your cooling tower goes down, then that means your wonderful brand new shiny chiller is offline. And when that happens in summer, that's a terrible situation to be in. And so making sure that all your I's are dotted and T's are crossed in terms of are you outsourcing that PM to a contractor? Are you doing it in-house? Do you have the right people deployed to the right places? Because really, really little things can cause something to go down. So feeling that all together, that's outside my expertise. That's my colleagues in O&M who do that, and then we try and work with them on that. So it's a challenge, and people do a great job, but you need to make sure those things are working together.
Sure. And the other thing is, I know that you're in your title that you're the commissioning engineer for the project, but obviously that you have I would think a hand going into the energy management side of it. So so it is the crossover. So like when you were talking about how that just going to recommission a building every 3 to 5 years. I know that that's the current standard that Lead was talking about, 3 to 5 years, which is a good idea depending on the type of building. But, my experience, and obviously that's what you're talking about, that universities are this dynamic process, right? The way one semester of classes may have morphed into different the way things are. Obviously, you had to think outside the box during COVID when maybe a lot of kids were not a student. hey, listen, when you get as old as I am, I call them kids, right? But the
So do
point
I.
is that you have all these students there that were there, and then all of a sudden there's nobody there, and that probably had to play havoc. And so, and the only reason I bring that up is that it's the dynamic nature of your position is not as simple as, let's say, an office building. And I'm not taking anything away from my brethren that do office buildings, right? But that's a different dynamic, right? The floors are, pretty consistent, and I think that's, kind of like what, we're going to look at here, right? I think that's the perfect lead in. The standard building is all one spot, all the floors go where, even if you have a university building, which we have here. I'm in Tampa, and we have the University of South Florida built um, a, uh, a teaching college down here downtown. It's this. I don't correct me if I'm wrong a little bit, but I want to say it's like a 17, 18 story. But it's all in one spot, right? And it's fed off a district loop. But the whole point is that where we look at you have this laid out wide campus. Obviously, this is just showing a little snapshot just to give the idea of the diversity. And so, like, you're right. That's where I didn't want to leave that idea of how things are always changing, and you have to address them on the spot. And I think you're right that continuous commissioning or continuous monitoring is the only way that you could stay up and be able to adjust on, I don't say on the fly is not quite right, but almost right. So what are your thoughts on that?
Well, I agree entirely, and I think your point there about that is right, adjusting on the fly. Also, you have this complex situation of ownership. So I've got it down there in the second point there. I don't want to say that ownership is always simple for commercial buildings. I know that's not always simple. But when we look at for us at UGA, we're a state university, so technically all the building and all the infrastructure belongs to the state, and we're the facilities manager. We kind of have the authority to run the show, but ultimately we're servicing the users in those buildings, which might be the Office of Research, it might be a particular college with particular funding, it might be a teaching space, it might be an admin space, it might be an athletics space. And so quite often what we can do is really dictated by those user needs in ways which can be quite complicated to solve. And then as an added complication, we often have different users in the same buildings, different offices, different funding sources, different requirements, sometimes on the same floors in the same building. And so trying to get all of that, and then they change around. Then space management necessarily has to move one unit out of this building into another, and so having that adjustability to be able to work according to all of those moving parts, I think is so important. The other aspect as well is just simply when you look at the number of buildings divided by a building every 3 years or a building every 5 years, the number of RX projects there would be. I think I estimated that you have to do a building in 3 days. I think was the it was 3.3 days was the amount of time you'd have to commission a building to keep up on that spec. I got me and my two technicians. That's not possible. Maybe a better man than me can, but I can't. So I think that's where, rather than looking at it as distinct buildings one at a go, it's about looking at the whole ecosystem together and having a more malleable model, which works to solve those problems.
Yeah, that's what that sounds like. I be honest with you, I don't envy you, because that seems like everything is always easier, right? And the guy at the top, or when when I work on office buildings and things, I call him Bob. Bob is my counterpart when we teach the energy management workshop. He calls them the C-suite guys. I call them the suits, because I'm this Brooklyn kid, and to me, those are the guys in the suits and the ties, and they're the ones that make all the rules. But the point is to get to them to understand what they're doing. It's easier for them to say, "Oh, just go fix it," right? And there's more to it in all of these things. And I go, so I don't envy you in your job, but it was kind of interesting. As a little side note, I remember when I lived in DC, and I talk about how things just come to mind. When I lived in DC, and you talked about how you'd have to commission a building, obviously at 440, and you're going to do them on any kind of regular basis. You're going to do them every 3 days, right? You'd be starting a new building. I remember when I was in DC and I used to go to the Smithsonian when I lived there for the year I lived there, and I remember taking the little tram that takes you to that you could go and visit. I don't know if it's still in operation or not. This was back in the 70s, and you would visit every one of them. But I remember the guy on the bus would tell you these little trinkets of knowledge, and he made this point of saying that if you visited every exhibit in every one of the Smithsonian museums. And if I remember right, it was like 2 minutes. If you spent 2 minutes in an exhibit, it would take you well over 2 years to see every exhibit, and you would never see them because they would be constantly changing them, right? But since then they've added 3 or 4 additional museums. So when you said that, that was immediately came to mind is like it's kind of like the other thing that comes to mind is like the sailors when they start painting a ship. By the time they get to the end of painting the ship, they're going to start all over again. So it sounds like this is the process that you're in, and while it's trying to save energy, it's a daunting task, and I can see that.
It's an enjoyable one as well because no two buildings are the same, and so it's got its pros and cons for sure, and it's nice being a campus manager and having ownership, over that. But yeah, the challenges are particular.
Yeah, I was just thinking about that. I'm sorry, I get sidetracked onto things, but you have this, you have your BMS, and that is your lifeline of understanding your peering into the soul of every single building, if you will. And obviously your data is as good as all your sensors. So how often do you are on a routine of replacing or calibrating sensors to make sure that it is as accurate as possible?
I mean, I wouldn't necessarily say we have a particular routine, just for the same reason as what you say before is the sheer scale of it is enormous. I think we can say we focus on our high energy use buildings, and but we're looking out for faults there. So my guys, Joe and Mike, excellent technicians. They're on our BMS, BIS all the time, focusing on loops on district energy systems, but also on particular buildings, tracking down errant actuators, fixed open dampers, sensors which have gone out of calibration, sensors which have just failed, all of that kind of stuff. But I think overall the thing we'll say about ongoing commissioning, and this is not earth-shattering I think to anyone listening, but a couple of things really, the phrase that we have in the department, and I'm not sure who originally came up with this, but you can't manage what you don't measure. And so you need to have the data there to see what's going on. I need to have that going on at scale. And whilst it's great to look at deep dives and to understand particular sensors or actuators which are gone on a particular lab and a particular floor of a particular building, actually what is so important is to have that macroscopic look of the whole campus, understanding which buildings or which areas have the highest EUI, which ones are suffering particularly in the winter, which ones are suffering particularly in the summer, where those trends are going, all of that good stuff, shall we say. And when you're doing that at scale, if of other people's campuses or anything like ours, we have 4 or 5 different BAS throughout that, shall we say, that historical diversity on campus. So and you want to avoid putting, and when you upgrade that, you want to avoid obviously putting new control systems on old air handlers which are going to be replaced. That's another complexity, is timing those renovations. And so I know what a lot of people do, we don't currently have this, but the whole single pane of glass, that layer on top of the BAS which everything feeds into, so you can see a whole campus in one go. I know a lot of other universities have gone down that route, and I think that's really valuable. Otherwise, you need to try and transition all of your different variety of BAS into one model, which you can look at your whole campus cohesively.
Yeah, it seems like the way, at least I would think that part of the way is that you start you look at energy, or you have some trending, I'm guessing, on all your buildings, and you're looking, trying to find, where are things are start to go out of whack, right? Because you have so many buildings, you can't be monitoring it all at the same time. I know there are lots of software overlays that you could do, but you were saying that you have multiple different systems, and obviously with 440 buildings and growing, right? I keep going back to that number because it's just daunting to me. No, and I mean that. I'm not saying that for anything other than it's just, I mean, I've been on campuses, I was at Tulane, and where there's a lot of buildings, but not 440 buildings. So do you have so many that you have to go over? And I'm sure you have a variety of BMSs, like you said, and it's like, that's a daunting task in itself to be able to just replace them to a single, right, manufacturer. Yeah. So have you considered the idea, and I think you and I talked about it briefly a little bit, just doing like an overlay and then putting in what I affectionately call protocol converters, which are like JACEs, where you can bring it and you have an overlay, whether it's Delta or ALC or whoever you pick as your overlay, that ultimately, that when you bid it out, is that another route that you were thinking? So this way you could bring it all together and still having 5 different or 7 or I don't know how many different systems.
Yeah. So it's not a route that we've gone down for now for various reasons, which are above my pay grade. But I recognize that clearly that's a good option to do if you can do. Certainly I think I think it's just the scale of what we have is cost prohibitive to us. To map all of those points into into that overlay. But certainly the the conversion of our BAS to the latest models and to the single sources is a major strategy in what we're doing in trying to control our campus and achieve ongoing commissioning at scale.
Sure. No, I could imagine. Again, I feel for you for having such a big building. It's probably rewarding. It's probably frustrating some days and rewarding on others, and maybe in the same day.
And I think one thing which is important, for others who are looking down the street, is a really crucial aspect of doing this well is just having a great working relationship with your contractors in this, because you don't just pay them and they stick the BAS in and that's it. There's a lot of optimization, a lot of calibration, especially in terms of the graphics. So you see that on the left are the graphics we got there for the STEM building. It's not just a one size fit all which they plug in there. We have to have a lot of discussions to make sure that all those different data points are feeding in to give us summary tables, summary graphics, summary stats, which are useful to us and our operation of the building. And it's not just to one person, right? It's not just in my department. Speak to O&M who are actually maintaining the department, the building, my department who are looking at energy savings. The whole gamut of everyone who's involved there. So that's quite a nuanced and challenging process, and I'm really grateful for my team and for the contractors who work together to produce that. So there's a lot of soft skills as well as the technical skills which go into making all this work.
And I'm sure in where you are is like every day is a new adventure. I hate to say it that way, but it seems like, because I can imagine so many things coming up and changing and being, like just the sheer age of the buildings, right? Because that was one of the things that I was thinking about. If you have a building that is, like you say, you have a 1806 building, I think, if I remember what you had said. Those buildings, while I think it's great from a carbon footprint that you are not, the embodied carbon is already been taken up already, but you now have other issues. Is that, do you have to deal, I guess it's a side question, when you have to renovate any of these old buildings, are they all on the National Register and you're in some of the things you could do, or?
Yeah, so our Office of University Architects, they have a whole part of that organization which does historic preservation. So there are lots of safeguards, shall we say, and important and valuable ones for sure. But and it also, I think that also so that's another impact in terms of, say, for example, on our North Campus is where our historic buildings are. That's where all the the really nice campus photography is. So, what we can do, we can't just stick a district energy plant there, for example. So there are other areas of campus where, more of our science and research areas where we can do that. And then but that does, our historic preservation, which is all good and proper, does have those limitations in other areas. And an interesting part of that was our steam plants. So we have this old smokestack, which is needs to come down, but trying to arrange all of that, between environmental protection, historic protection, safety operations, that go all the way up to the border regents and the governor, I believe. So there's there are, again, complexities upon complexities. It is
the reason I was asking that is from obviously from having dealt with facilities like at Tulane, where there's some like buildings that date back prior to the night, back into the 1860s and 70s, and doing anything to those buildings when you renovate them was literally almost an act of Congress to try and, while they had LEED standards to do a whole bunch of things, and that was a private college, not a public college like yours is, like you said, it's run and financed by the state. But I remember I would argue with them about, you want to make this building more efficient, but I got to leave the old drafty windows in. You won't let me fix it. Do you have that same problem, that or are they at least a little bit more than where they understand that while it's on the register, that I'm trying to get the full. I want to give everybody the full.
I think that those are
is it just as bad where those kinds of things occur to you, or at least they're a little bit more applied?
Yeah, I think there are some concerns, for that, some limitations, shall we say. Our historic area is pretty limited. A lot of our major expansion was on the 60s. So while I do talk about Old College 1806, really that's not the one which concerns us as the challenge. It's more the 60s vintage, which was where we had rapid expansion, and the limitations of those factors, I think, are the ones. But it's a factor. It's not the biggest one, but historic aspects do play their part.
Okay, well, and it was funny when you talk about buildings done in the 60s. Well, I didn't start my career in engineering until the later 70s, but I did work on buildings from the 60s when I would go and renovate them. And what at least my memory, because a lot of it has all been renovated since then, but at that time it was very common to do dual duct systems, constant volume, dual duct, and for those folks on the call that don't know what a dual duct is, I'm just going to bring it real simple, is that you had one duct that was bringing hot air to the space, to basically a mixing box, and then you had a cold duct, and they had dampers, and it would blend, and it was like the perfect system because you always got temperature. There was never overcooling. There was never overheating. It was an energy pig. It was the only way to describe that for the most part, because you were always cooling down and reheating. But do you still have systems like that, or have they been retrofitted?
We have plenty of those. Yeah, we got a load of those. So I say that our campus is not only an institute of higher education; it's also like a living museum to HVAC evolution. Through over the decades, and we got plenty of those. And like you say, they kind of work really well if you don't care about energy.
Exactly.
They're very robust. They're made to high levels of craftsmanship and everything. And once you set them up and running, they run well because they don't have a lot of moving parts. They don't have a lot of actuators responding and trimming and adjusting. And so they're the Cadillacs which just keep going. But so they don't actually necessarily attract a lot of investment to update those ones. So you have those energy hogs which keep on doing what they're doing, and then you have the other trickier buildings which are, should we say, a bit more finicky a lot of the time, but actually do better EUI.
Oh yeah, no, I get it, and that was the reason I bring that up, because I think it's easy for everybody to understand. It's like if you're dealing with a brand new building or a reasonably new building, they don't have any of this constant volume, energy wasteful system. But then again, they don't have any complaints on temperature and humidity problems for the most part. I don't want to make it say it's a panacea. Everything has its own set of issues, but I think you're right you know, years ago, you know, while I didn't design any of those systems, but well, some of my, I'm sure some of my staff would say, of course I did. You know, I drew on you know, I used to draw on a stone, right? But that they joke about with me. But I think the reality of it is that, you know, there's a trade-off today, right? Of energy versus comfort, and there's a lot of different ways of doing it. There's nothing really wrong with any of them, but you gotta, everything requires, but there's so many more moving parts, and I think that's you said it very well. Um, so let's move on. So now you've done your existing building commissioning on some of these buildings. So I guess this is showing you're trending over the last 6 years.
Yeah, so when Kevin was originally putting this together, one thing he asked for, and I'm very grateful for this, was just any case studies of things which went well. So whilst I have talked about doing things at scale on a campus at large, we do still look at particular buildings, and I think it's very much about focusing our efforts on buildings where you can get a good ROI. Well, it's not really return on investment because it's our own in-house work, but you get a good results from our limited hours which we can put into it. And so one building which we looked at was our Science Learning Centre, and I'd highly recommend any other facilities who have a facility like this to look closely at it. And the reason is because it's a lab building. There are, I think, 68 fume hoods in that building. So there's a huge amount of airflow going through there, and in a hot, humid environment, that's a lot of money. That's a lot of energy.
Oh yeah,
that's a lot of money. But of course, most of our buildings with fume hoods are research buildings. There's very little we can do there in terms of bulk energy savings. Sure, we can optimize, we can trim, but it's difficult for us to do those bulk savings. The Science Learning Centre was different because it's entirely undergraduate teaching. So there was a decision made, I think it was late 90s, early 2000s, to move a lot of the teaching from the biology building, from the chemistry building, from the physics building, and consolidate that into this multidisciplinary building, which is great. It's a great decision. The issue was twofold. Was once when we went into pandemic mode, before I started working for the university, I was studying, but before I started working there, all the schedules were taken out, and the older abundance of caution mindset, and fair enough. And so when we attempted to put it back in, the building pressurization went totally out of whack, and we just couldn't maintain it. So we looked into it, and one of the things we found was, when you have a lot of with a building like this, undergraduate teaching, just a number of students coming in and out of that place is incredible. And the number of classes, the turnaround that you have, and when you consider that that type of use of a fume hood is very different to a dedicated research with maybe one or two graduate assistants using a fume hood. Basically, it gets dirty. You got a lot of dust, a lot of chem wipes, a lot of little scribbled bits of notes which students have written on, get sucked up into the fume hood and lodged in the air valve. And what it meant was the air valves got dirty, they got out of calibration, and they were just pumping way too much air through the building.
Sure.
So getting through that, cleaning them out, recalibrating them, our contractors helped us out on that, and then installing a building pressure sensor just to make sure that we were maintaining positive pressurization. It took a lot of work, but it was worth it because we were, first of all, saving airflow, and then also able to put on a schedule for evening and weekends. And so, we were looking at around over 25% energy savings over a 6-year average, which is usually unheard of, but is possible because there's dual parts of significant airflow savings, and also able to do weekend and evening occupancy schedules. So yeah, I highly recommend that to anyone who's got a building of that similar profile, which is that's an unusual one. But yeah, we can talk about other buildings which we have, but I'm cautious of time. But
yeah. Oh yeah, and but yeah. Well, what I find interesting though is I just find to me it was fascinating that you look at the electric consumption went down by 27%, chilled water consumption went down by 28%, and then steam went down by 27%. It's like they all kind of track each other on the percentage, and that's you couldn't have scripted that any better to for what you did here is
there's an
now
interesting balance there between us being, you know, a cooling dominant environment, but of course, you know, low, especially in an undergraduate building, you know, they're not classes going on in the summer. So, you know, if there were classes going on in the summer, then the chill water load would be a lot higher, of course. So it was, yeah, it's an interesting balance point, which is kind of fortuitous. So yeah.
Sure. No, I get it. Let's see what we got here. Here we go. So you have your ECMs that you did for all your existing set. You call them, like, you know, commissioning agents traditionally will call it existing building commissioning. Which adequately, it makes a lot of sense to call it existing system commissioning, which is another way to look at it. So these were your, this way I could put it, is your path to be able to be successful.
Yes, I think these are, you know, our top hits, shall we say, you know, where we found over the years that maybe been in operation for 3 years, my department, where I think we find, you know, the best bang for a buck, shall we say. We'll talk about our campus-wide ETMs rather than individual buildings. So HVAC occupancy schedules are things which we can manage centrally on our BAS, and we built in a module which allows us to push that out effectively. Demand control ventilation calibration is, you know, that requires a bit of work every now and again to make sure that operates correctly. And demand response is quite useful. And if we just want to hop onto the next slide there quickly, I might make
Sure.
it a bit. But this is something which my boss Jason put together recently, is just analyzing our electricity costs for 2024. So you've got a few things going on there. The base load in the dark red, which you see on the graph there, connected base load, which our utility provider bills us at, you know, that's calculated each month on a certain formula, and we get billed uniformly across that at a certain rate. But then the pink there is our RTP, our real-time price, which elevates according to supply and demand on the energy markets. You know, the background rate of that is 2 cents per kilowatt hour, which you're going to see there in February and March, April, pretty low loads. But when you look at, you know, peak summer, and even in January now, we're seeing peaks that elevates enormously, and you can get background values of about 20 cents, and our highest values are 464, I think, cents per kilowatt hour, up from 2. So all that to say is that the cost is really not uniform. It really is focused and intensified down to particular hours. Obviously, you know, there's early evening hours, weekdays in the summer, but also actually in the winter as well. And you see the pie chart on the right there, you know, 300 hours, you see that in the little cutaway there, is for, you know, really quite a significant portion. The RTP is 39%, and you can see it's over 50% of that 39% is accounted for just 300 hours out of the year. So that's so all that to say is that demand response, where we have this module on our BAS, we can just click a button, and that, you know, widens the dead band for our set points by 1 degree, 2 degree, or 4 degrees. That's just shaving off the energy use at those times, but maybe 1 to maybe 4 or 5%, I don't know. But the point is that when that 1 hour's bill is over $80,000 for that 1 hour, and that's just the RTP aspect of it, it can make a difference. So yeah, that's one aspect there.
Now, when you like, obviously, when we wind up like as doing energy projects, right? Well, I always tell all my clients that, you know, while we are going to tell you how much money you're going to save based on your average cost per kilowatt hour, I said, we're going to be, you know, you're going to judge me only on kWh that we've saved, right? And sometimes that's a battle. I said, you know, I got to base it on money, but the cost of money goes up and down. The cost of energy goes up and down. Now, when you do this, because of this, do you normalize this to an average cost per kilowatt? Is that really work based on this model? That's the reason I was asking, is because it seems like, depending on, if I was going to do something that was more winter dominant, let's say, then I probably don't want to use that average cost, because they would be skewing it too much based on what's going on in the summer. I'm just asking, is that what you guys do?
Oh yeah, for sure. Yeah, so that's more more by boss Jason Perry, director of UEM. That's what he makes some impressive spreadsheets, I can tell you, to
I bet.
take all this detail and churn out these values. So yeah, absolutely. Yeah, you need to have quite a nuanced understanding of how bidding works. And electricity is one thing, but gas pricing is a whole nother layer of complex. And then I'm trying to work out that and hedging on how much to purchase and nominate for each month during the winter, and then the relative cost of that compared to when you have to switch to fuel oil. There's it's pretty complicated.
We just out of curiosity, and this may not be in your area, but of where you operate, but in almost all states, and I believe Georgia is one of them, where gas is deregulated. So do you wind up going to like a broker, and when it comes time and you buy gas,
So we have
pricing
it's
for the
interesting.
next 3 to 5 years?
We have two suppliers. We have one gas marketer which supplies what's called our firm load. So we're guaranteed 18,000 decatherms a day. And then we have another supplier which gives us our interruptible load. And so that's where we have to, nominate how much we need to use how much we want to use a month on the during the winter. And then when it's if we use more than that, then we have to pay a lot more. If we use less than that, then we get some refunded, but not at the same rate. So there's some challenges there.
All right, all right. And so we're to our question and answer section. I think we left, about 9 minutes or so for, and I could see that that between the chat and whatever more is, that we have like four. Hopefully that's like a bunch of questions. So Sim, what do you got for us?
Thank you so much, Alan. That was amazing. That was so much information. Love it. I do see a lot of questions that are in there. To start off with, there's a question from Michael. You mentioned 35%. He's asking if that is the summer utilization percentage or all year. Are there any absorption chillers to use the steam during the summer?
Yeah, so it's like an all-year number. I'm not privy to the calculation, so I guess I'm probably not allowed to say the name of the company, but a very large and very reputable nationwide engineering firm did our energy utility master plan, and I think they based that off models elsewhere applied to our model, and that's what they came up with. It's probably not exactly 35%. I'm probably not getting that quite right, but it is in that ballpark, and yeah, that's the annual value, just taking into account the number of steam leaks and absorption from there. In terms of absorption chillers, no, we don't. But that's obviously something which we want to do, and but we're going to loop that together with our campus-wide energy steam to hot water conversion, right? So when we go to those self-contained districts and close the heating cooling loop, that's where we will aim to use that there. But of course, in that case, we'd be moving away from steam, so it's more heat pump chillers and all that.
Interesting. The next question that we can pick is, what was the biggest challenge that you faced while converting the system from steam to hot water?
Yeah, so we're not doing that yet. That's part of the big plan, and the biggest challenge there is, well, I guess a number of things: the dollar amount, the scale of the project, to try and understand how to do that all together, which is why we brought in this external firm to do the master plan for us, and we're in the stages of deciding and how we want to go forward with that. And I think part of the challenge there is just reparceling out our campus. So we cannot possibly do it all in one go. So it's really about parceling it out and then transferring different regions at a time. And one of the things which you need to consider with all of this is when you go from steam to hot water, you're changing your delta T over your heating coils. So at the moment, I think it's 180 degrees delta T you get from the hot water. So the steam to hot water conversion rate brings our hot water temperature up to 180 degrees. Sorry, the delta T isn't 180 degrees, but 180 degrees going into our cooling coils. And when we go to heating hot water, that's going to bring it down to like we haven't even, there's so many different options, and we have to try and enforce a standard for all our buildings going forward. And that is probably the biggest challenge. Is it's not just the large infrastructure, it's actually all of the downstream units, and making sure that we future-proof what we're building now to be able to deal with that. And then all the existing buildings how do we answer that question? And we don't have a clear answer for that.
And then I would also think again, it's your campus, but I would think that you'd probably have to, it'd be in a very evasive, I think you and I talked about that before, it'd be a very evasive thing to be able to run the new hot water lines, because obviously you'd want to be able to keep things running simultaneously while you're putting one loop in before you decommission the other loop. So, so not only is it just the cost of the pipe, it is a disruption to the campus. And
the dollars per foot of laying this piping is eye-watering. It's just remarkable.
Yeah. Oh, I can imagine. It could be, when we were doing some stuff here in Tampa, we were looking at the neighborhood of running chill water piping, and again, this was in the street, and we had to worry about asphalt and everything else, but it was upwards of $1,500 to $2,000 a foot. Mm-hmm. So I'm not, and somebody was already digging the hole because they were putting in other infrastructure in, like sanitary and storm and water. So I can't even imagine with you if you're just digging it up just for what you're doing. So anyway, I just find that I can understand why it's a daunting task. Sim?
Yes, Al. For the next question, this says, with so many buildings in your management, how do you prioritize which ones to commission first?
Yeah, great question. So what I would say is that in one way is just that whole thing about like we didn't really do building by building recommissioning. What I would say is that when we have a particular building, which is a particular issue, then we would do a focused commissioning project on that. But it's really often that is more to do with user concerns, or maybe a very, very particular energy project in that area. The example I gave of the Science Learning Center was one which we did because it was that unique building, which had so many fumes in there, but it was a teaching building rather than a research building. So what I would say with that one is, to anyone who's trying to think this through, is just think very carefully about where are there any buildings which stand out as something where you can get a good bang for your buck being your time more so than a dollar amount. But then I would also say is obviously you want to commission every new building very well, and that's where I think we put a lot of our effort is in making sure that gets done well. But if you've got a smaller campus which is more manageable, then if you can have a retro commissioning schedule, then make that work. That would be a brilliant way to do things. But otherwise, I would say the better thing to do is to have an ongoing commissioning program in general, and then very, very focused recommissioning on particular buildings which stand out and are unusual.
Got it.
Perfect.
Got it.
Yes. For the next, I think you just mentioned about retro commissioning. There is one question that says that, do you have a retro commissioning schedule?
Yeah, so the answer to that is not particularly no. It's not really, doesn't really work to do it over that scale. What I'll add to that question, actually, the one about prioritizing as well, is something to bear in mind is, you can do a retro commissioning program, and then you get all those ECMs. The question is, some buildings you can do ECMs in, and some of them you can't, right? So you can predict that if you've got a really old antiquated air handler or a really old antiquated BAS, one of the big ECMs you're going to get is to replace it. Well, if you know that a particular unit can't attract the funding in order to put that in, then I would say don't bother putting the money into the retro commissioning project if you're not going to be able to do the normal recommended outcomes. Conversely, if you've got an area which has got pretty tight BAS, and then you can optimize and trim things here and there effectively, then it's probably worth putting effort into that building, even if it is quote unquote a better building, because you can actually do more with the findings that you have. That's another thing to consider.
Interesting. And since it's 2:59, I'm just going to pick one last question before we wrap it up. This question says, do you use a fault detection and analytics software, or everything is done by the BAS?
Great question. So we are moving towards that. We're trialing a system, and I hope to, yes. But again, doing things at scale is the challenge. So it's about sort of the pilot stage, We were thinking of including that as a slide, but as I didn't have a lot of really hard, good examples to talk about, but we steered away from that. But yes, we are thinking about doing that. But again, it's that the pilot is very much figuring out what can we learn from our implementation to make us be able to leverage this at scale the most effective way that we can. So yeah, I highly recommend fault detection. Yeah, definitely go down that route, but think carefully about how to implement that at your particular institution.
Perfect. Thank you so much. And with that, thank you so much, Al, Gordon, and Kevin for the great presentation and discussion. And thanks again to our sponsors, Blue Rhythm. That's going to be a wrap for today's webinar. But before that, now for the audience, are you trying to cut energy waste but not sure where to start? Let's break it down together. The upcoming session, Essential Techniques in Calculation for Energy Managers and Commissioning Authority, is packed with real-world tips, easy to follow calculation, and smart strategies to boost efficiency and save cost. It is going to be happening on March 20th from 2 p.m. to 4 p.m. Eastern Time. You can learn more on our website. That's going to be www.energymanagement.org. And with that, again, thank you so much, speakers, and thank you to everyone who joined us today. Have a great day.
Bye-bye now.